question 39 from the GATE 2019 EC paper, where we are asked to find the state transition diagram for the sequential circuit shown below. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic.
So in this question, we are given the following sequential circuit, and we are asked to find out what the representative state transition diagram is. So let us first find out what the next state equations are. So the next state equation for a D flip-flop is Q plus is equal to D. That is, Q takes the value that D had when the sampling edge of the clock hits. So we will have to propagate Q and Q bar to the D input along with A to figure out the equation for D. So you have Q that propagates till here, and Q comes to 1 and Q bar comes to 0. So the idea is, if A is 1, then the output is Q, and if A is 0, the output is Q bar, because this is a multiplexer with A as its select signal. So that is the equation of this signal which comes here, and it is the NAND of these two that comes to D. So D is Q and QA plus Q bar A bar, the whole bar. It's the NAND of these two expressions. And that is what I have written over here. And from the above equation, we need to form the state table, right? So when Q is equal to 0 and A equal to 0, you will find that because Q is equal to 0, it becomes 0 bar, which is 1. And of course, since Q is equal to 0 for this, you will get 1 here as well. Finally, when Q is 1, right? So when Q is 1, we can eliminate that, and we can eliminate that, we can eliminate that. So you will become equal to A bar. So for 0 you will write 1 here, and for 1 you will write 0. So let us now draw the state graph from the state transition table. First we draw two nodes that correspond to the states Q equal to 0 and Q equal to 1. So we'll go over each state and each input to find out what the next state is. For the current state Q equal to 0 and current input A equal to 0, the next state is Q equal to 1. So we draw an edge, a directed edge from the current state to the next state, and write the current input that is responsible for that. Similarly, 0, 1 gives us 1. Interestingly, 1, 0 gives us 1. That is, when the current state is Q, the next state is the same as the current state. So the directed edge is from and to the same node. And of course, this is for A equal to 0. And finally, for A equal to 1, you get that for a current state of 1, you get it traverses to the state 0. Comparing with the state graphs shown for the problem, you will see that the state graph C matches what we have drawn here. Thus, the above table corresponds to state graph C, which is the required answer.